Hello, I'm here today to show how to wire up a basic robot. This is just going to be a basic chassis with 4 wheels, and we're going to get this connected to a rev expansion hub, as you can see here. It's a little bit of an older technology at this point, but the basic wiring principles carry over to the newer FTC components as well. So it's a quick run through of materials. We have our basic chassis with 4 motors that have AndyMark power pole connections. You can see they're AndyMark Nevrest 60:1 ratio motors, AndyMark's slowest motor, I believe, that they offer for FTC, but also the strongest torque. That's just kind of what we had laying around. We have the expansion hub. We have these adapters that go from the AndyMark power pole, that's what the motor connection is, to this connection. I'm not exactly sure what it's called, but that's what connects into the expansion hub. Some motors, the rev motors will come, you might not need this because instead of a power pole, they'll have this connection directly on the motor. It just depends on what motors you have. We'll have a switch to turn the power on and off to the rev expansion hub, and we'll have this battery. We also have some encoder wires for the motors. I have 2 different kinds. This one we directly soldered the wires because it comes with, this is the connection side that goes to the motor. You can see it's a little bit wider and has the 2 little protrusions out of the plastic there. And this end also has 4 wires, but it's a little bit smaller, and the 2 little protrusions are close together in the middle. So this one we soldered the 2 types of connections together, and on this one we have a little rev adapter that they actually make to convert between the 2 types of wires. So either one works fine. Just to be demonstrating them both today. We also have a USB cord that goes from the phone to the expansion hub. And then we also have the driver station and robot controller phones that we will be using. The first thing to do when wiring up this robot is you're going to have to connect the expansion hub to the actual robot here, mount it. This one, we actually put a layer of non-conductive cardboard underneath, relatively thick piece, you can see, compared to the rev hub itself, to prevent any static interference. It can work while touching metal. In our experience, we think this has actually helped us to not have the robot have as many unexpected shutdowns due to static. Different resources will say whether or not this is actually helpful. But yeah, have it nice and supported on both sides, and make sure to leave an open spot for the USB cable to come out on this side. Now that the expansion hub is securely connected, the next step is to plug in the wires. One quick note is that this expansion hub is close to the edge. In an actual competition robot, you kind of want to put the expansion hub closer to the middle if you can, just to keep it protected, because it is one of the more sensitive components of the robot. If it gets slammed into, it can either cause the robot to shut down in the middle of the field or even break the hub, which it is also a more expensive component. Don't really want that to happen, so just for protective purposes, keeping it nearer to the center of the robot is ideal. For this robot, it's not going to competition, it's all right. So, we have these motor power pole connections here, and first thing we need to do, you'll notice, is that this is the motor ports, and these don't plug in. That's where these adapters come in. I have to plug these into the motor wires, and then plug that into the expansion hub. So I'll be right back after I do that. A quick word of caution for putting in these adapters. Please make sure red lines up to red and black lines up to black. You can see here, this wire extension was crimped incorrectly so that black and red go to the wrong one. This will cause the motor to run backwards in practice. For other components, reversing the polarity like this could be harmful. Not really for FTC, for most of the stuff that teams will be doing, but if you want the motor to run the right way, make sure you do this correctly. Now, changing the direction won't require re-crimping the wires or anything. Just need to push these apart, which can be quite difficult to do sometimes, and then realign them. Sometimes what helps me to get these apart is I use a little hex wrench, and I gotta be careful not to damage the inside. I can kind of just use this to push them apart. Finally got these apart. With a lot of effort, I actually ended up having to get some pliers to pry them apart. But you can see on each half of the connection here, there's 4 sides. 2 of them have a little indent and 2 of them stick out. So you can kind of slide them together. To make sure they're in the right direction so that black and red will line up, what I typically do is I'll plug each one in separately. So I'll plug in the red, like so, and then I'll plug in the black. Probably won't be able to get it actually in there because the red's in the way. Oh, this time I can. And then I take it apart, keeping their directions together. And then I can slide the groove into the slot here. And now the wire is correctly oriented. This was probably done deliberately to reverse the polarity, like to make the motor run backwards, for example, for that wire. It's better to do that in the code than in the wiring. In my experience, it's just easier and don't have to rewire it all the time like this. Yeah, but so now that once this adapter is connected to the motor, this is motor wire adapter, I can now plug this into the Rev expansion hub. There's 4 motor ports. Can connect to the second expansion hub to have another 4 motor ports, and that's the maximum allowed by FTC is 8 motors. So yeah, I'll go ahead and put this one into port 3. The ports are labeled 0 through 3, not 1, 2, 3, 4, it's 0, 1, 2, 3. So 3 is the last one and closest to the left. So go ahead and plug that in there. And then do the same for the remaining 3 motors. Here's all 4 motor wires with their adapters plugged in. When removing these wires, you can't just pull. That will damage either the cord or the expansion hub. You have to press this little tab right here, squeeze it, and then you can pull it out more easily. And that's the proper way to do it without damaging the wires or the hub. The next step is to choose a place on your robot for the battery. There are 2 types of batteries, one that looks like this, and then another Rev battery pack that looks like this. They are different in size and shape, so that might weigh into which one you use on your robot, also just whichever one you have. This one is a newer model, so if you've ordered parts more recently, you might be more likely to have this type. One does have the power pole connection, and one has this connection here. I'll show in a second how to accommodate for either one of those. But for now, we're gonna use this battery, and kind of similar to the expansion hub, you want it to be in a protected spot. It is decently heavy, so weight is also a consideration for placement of this. Not put it out on like some arm that sticks way out here. It's just gonna fall to the ground. If your battery gets disconnected in the middle of the match, nothing you can do since you can't touch the robot, so you want it to be securely in place. I'm gonna put it right here. Again, not very protected of a spot, but it's secure for the purposes of this demo bot. And I'll be right back after I have that connected in there. All right, the battery is now securely in place. One other factor that I forgot to mention before is ease of charging. We would often 3D print or otherwise build like a case for the battery that it could go in, that we could open, take the battery out, put it on the charger, or make it easy to access the wire from outside the robot to charge it. This is not necessarily the most ideal setup for charging using zip ties like this, because it can't be done and undone easily. You have to cut the zip ties and use new ones every time. That's just another thing to consider. So now we need to connect the battery to the Rev expansion hub. I'm going to use this switch to do that. You can see it here. This allows us to turn the power on and off. It's very helpful. It's required by FTC rules. Can't just have the battery directly connected to the expansion hub. Just plugging it, unplugging it to turn off. Having a switch is necessary. So if we were using the Rev battery pack here, it could connect right into the switch, just like this. And that's great. But for the battery that we're using, it has the power pole connection. So similar to the motor, we made an adapter right here. So you can go ahead and plug that in. In general, if you don't have the right wire connections, making an adapter is pretty easy. I'll post another video about that at some point, about soldering and crimping wires, especially with Andy Mark power poles. It's something our team has found super useful in making connections. Yeah, so now we have the adapter. It's the same type of plug-in as the Rev battery pack, so we can put it into the switch. And then we can put the switch into the Rev hub at its desired spot. Here you can see the battery connection. Unlike the motors, this wire you can just pull in and out. There's 2 battery connections right here. If you crimp your own wires, take note that this open one, the female connection, is the one that we want to plug in for power. This other one is for daisy chaining expansion hubs. So if you want to have a second expansion hub for increased motor and servo count, you can do a wire from here to the next expansion hub, and that'll supply it power. I think in a series format, although I'm not completely sure about that. But yeah, if you don't crimp any wires, it won't fit into the wrong one, so you don't have to worry about that. But input power goes into this open connection right there. Now that the battery is connected, you should be able to flip the switch and have the blue light turn on in the expansion hub. It won't turn green yet until you have the phone connected, which is what we'll do next. Connecting the robot controller is very simple. You can just take our phone here, plug in one side of the USB, the one that fits into the phone, and then you can just plug the other end into the top of the expansion hub. That top expansion hub connection can cause some difficulties with the wire shaking and being bent. You don't want to bend it at extreme angles. It can damage the wire. And obviously you'd want to have the phone secured better. We found that Velcro is really useful for this. For this connection, some of the reason I had trouble getting it in actually is we found a part to kind of hold this steady. It works all right. We probably want to put some more support when we build the robot. Usually we'll support the wire up past this ferrite and zip tie it down so that it stays in place. And it's not something that we're unplugging and plugging often. This one we unplug and plug, and this USB point can actually be a common point of disconnect as well. So just things to keep in mind when using the USB connections. They're the easiest to kind of get unplugged by accident in a match. We've also found, like I said, Velcro is really useful for securing the phone. There are also lots of online phone holders by other teams, and that could be more useful if keeping the phone in a certain spot for using for Euphoria, for example. It can be really helpful for that. So yeah, just as long as everything's secure, you should be fine. So everything is all hooked up now. This robot would technically run if it's configured and a program is loaded on it. However, the wires are an absolute mess. Neat wiring is extremely important for an FTC competition. We've learned this the hard way. When the wires are messy, you don't know what goes where, especially once you start getting more expansion hubs, sensors, lots of wires going all over the place, encoders. It can be hard to trace a problem. Also, we've had problems with electromagnetic interference between wires. And that can happen especially when you run wires through channels like this. Although that is often the best bet to keep them organized. And just with power wires like this, it's fine. It's more the signal wires of encoders and servos where that becomes an issue. So using zip ties, we found these little things. I'm sure you know what a zip tie is. But it's super helpful for keeping wires kind of under control. You also don't want them hanging all over the place because they could get tangled up in another robot. It might not, this robot probably wouldn't pass an inspection at a competition because it would be risk of entanglement because these wires are literally just all over the place. But yeah, I would not suggest just, stuffing them all in the middle and being ha, it's not entanglement because of electromagnetic interference and just for debugging problems, as there will inevitably be problems. Just that's how robotics works. So yeah, I'm going to go ahead and zip tie these back into a more neat configuration so that it's easier to find the wires and it's easier to just use the robot without having everything get tangled. Labeling is also super helpful. If you put a little piece of tape on a wire that says what each end is connected to, that's also super helpful. And lastly, these plastic wire wrap things, I don't know if you can see that, but you can wrap multiple wires in here and it's great for keeping bundles of wires together and organized. Here you can see all the wires have been cleaned up and tied back using zip ties. Super helpful for wire management. These running along here are the motor wires for these 2 wheels. These ones here are the motor wires for these 2 wheels. In a real robot, I want to put some backing here to protect these wires since they're exposed to the outside. Notice I put the switch facing inward. It's easily accessible, which is required by the rules, but also not facing out here so that a robot could just bump into it and switch it off. It's accessible by a human, hopefully not by a competitor robot. So yeah, this is just showing the wires nice and tied back, not dangling around anywhere. Yeah. As a final note, I mentioned the encoder wires at the beginning. These are not required. This robot will drive, and for a teleop program, it is unlikely that you'll need an encoder wire unless you're doing some sort of reading from the motors, like what position they're in. This would be used more in an autonomous. You might even use a gyroscope or other type of motion sensor to measure your motion. Encoder is just one option to do it. If you choose to use the encoders, get your wire that I showed earlier, either the soldered or the one with the adapter. So you can plug the larger side with the spread out port into the motor, and then plug the other side into the corresponding port onto the expansion hub. It's important that you plug it into the same port as the motor's plugged into. Otherwise, it'll take this motor reading and map it to the other motor, and which is not what you want. So this one's plugged into port 1, which is the second port because it's 0, 1. So we go ahead and plug this in there. And then you could repeat the same for any motors that you want encoders to be connected to. Thanks for watching. That concludes the wiring up a robot video. Feel free to comment if you have any corrections or questions, because I'm far from being an FTC expert. That is the basics of how to wire up a very simple 4-motor drive robot.